Well, howdy, y'all, and welcome back to iChem, Honors Chemistry here. And we are in our unit on the mole and stoichiometry. We've already discussed the mole, and we've talked about how we can go from grams to moles. We've talked about percent composition and empirical formula and molecular formula. Now, let us get into the big word, stoichiometry. So where are we going to begin? So let's consider a Big Mac. Big Mac. Ooh, there we go. A Big Mac. Yum. Good. What is the ratio of hamburger patties to Big Macs? Well, we first have to analyze our Big Mac, don't we? Let's look at our Big Mac. What do we have here? There is a hamburger patty, and there is a hamburger patty, so we have two hamburger patties, right? Okay. And what else do we have? We have one, two, three slices of bun. So we'll say we have three SBs and two HBs. And what else? It looks to me like we have one piece of cheese here. So we have one cheese. We'll call it a CH. One cheese. There we go. And of course, you all know this is really what? Two all beef patties, special sauce, lettuce, cheese, pickles, onions on a sesame seed bun. Yes, that's a Big Mac. Good. So what is the ratio of hamburger patties to Big Macs? What did we say? We said we have three hamburger patties plus, not three. No, I didn't say three. I said we have two all beef patties. So two hamburger patties, two all beef patties, special sauce, lettuce, cheese. Okay, one cheese, pickles, onions on a sesame seed bun. But there are three slices of bread in that bun. Good. So we have two hamburger patties plus one slice of cheese plus three slices of bread, and that'll make me one Big Mac. Got it? One Big Mac, not here we go. One Big Mac. There we go. My Big Mac. Good. What's the ratio of slices of, oh, excuse me, what's the ratio of hamburger patties to Big Macs? Well, if I make one Big Mac, right? I make one Big Mac, how many hamburger patties? Well, my ratio would be what? One Big Mac per two hamburger patties. Got it? Yeah, that makes sense. What's the ratio of slices of bun to Big Macs? Well, slices of bun. Here's my slices of bun. So I have one Big Mac over what? Three slices of bun. And so, okay, good. So do we have anything about cheese here? Now, assuming you had plenty of cheese and buns, how many Big Macs could you make if you had 24 hamburger patties? Well, here's the way I would do that. I have 24 hamburger patties, right? And I have my ratio, right, of hamburger patties to Big Macs. I make one Big Mac for every, what, two hamburger patties, okay? So look at this. This is like dimensional analysis, sure is. And what do I get? I get 12 Big Macs. So if I start off with 24 hamburger patties and they have lots of cheese and lots of slices of bread, I can make 12 Big Macs. Cool. You know what you just did? This is stoichiometry. Stoichiometry. That's exactly stoichiometry, right? Good. So let us move on to our next question. Consider, aha, so I have a reaction here. Yes, okay, there's a reaction. And it's just kind of like what? It's kind of like this, right? It's kind of like, how do I make Big Macs? The question here is not how do I make Big Macs, but how do I make oxygen and nitrogen dioxide? Cool. So what is the mole ratio between N2O5 dinitrogen pentoxide and nitrogen dioxide? Okay, let's talk a little bit about stoichiometry, right? So what is stoichiometry? I don't know what's a good definition of stoichiometry. How about quantitative analysis quantitative analyses of a chemical reaction. And specifically, what are we looking at? Oh, I guess another way to say this is what? This is the study of the masses of reactants and products in a chem reaction. I'd buy that too. Both of those make sense to me. So that is stoichiometry. Now, one important part of stoichiometry is the mole ratio. So what is the mole ratio? The mole ratio is a ratio between any two components in a reaction based on their coefficients in a chemical, we better put balanced here, balanced chemical equation. Okay, so we look at the balanced chemical equation, and those coefficients relative to one another represent a mole ratio. So when we look over here, what is the mole ratio between dinitrogen pentoxide and nitrogen dioxide? We look at what? We look at the ratio of their coefficients. These coefficients represent not just the number of molecules that react. 2 molecules of dinitrogen pentoxide react with 4 molecules, decomposes into 4 molecules of nitrogen dioxide plus 1 molecule of oxygen. Not only molecules, but moles. This says 2 moles of dinitrogen pentoxide decomposes to form 4 moles of nitrogen dioxide and 1 mole of oxygen. Okay, so then what's my mole ratio? My mole ratio between dinitrogen pentoxide is what? 2 moles of dinitrogen pentoxide for every what? 4 moles of nitrogen dioxide. What's the mole ratio between O2, oxygen, and dinitrogen pentoxide? Well, that's a piece of cake. Oxygen is, okay, what? What's the coefficient here? 1 mole of O2 for every what? 2 moles of dinitrogen pentoxide. Okay, cool. So that's mole ratio. How many moles of NO2 would be produced if I have 27.2 moles of dinitrogen pentoxide? Hey, remember how we handled this? We said, hey, we have 24 hamburger patties. We applied what to it? Hey, this is nothing but a mole ratio, right? This is a mole ratio between Big Macs and hamburger patties, right? What goes on the top of my mole ratio? What I want. What goes on the bottom as the denominator? What I want to get rid of, right? Good. And so that's what we do. So let's come here. Ready? What do I have? I have 27.2 moles of dinitrogen pentoxide, right? And I'm going to multiply it by a mole ratio. What do I want? I want moles of nitrogen dioxide, so we put moles of nitrogen dioxide. What do I have? Moles of N2O5. Good. So what's my mole ratio from the reaction between these? I have 4 nitrogen dioxides, and I have 2 dinitrogen pentoxides. There we go. It's a 4-to-2 mole ratio. What do? How about 4.54, if I know my math? Multiply it by 4 divided by 2. That's the same thing as multiplying by 2. 2 times 2 is 4. 2 times 7 is 14. Carry the 1. Yay! I'm a winner. There we go. I could produce 54.4 moles of nitrogen dioxide. Now, what do you notice is critical? Key. Hey, we want to write down our units. Once again, units are very important to make sure we're doing the problem properly. Cool? All right. You guys try this one. Bring me back when you're ready. Okay, what is the mole ratio between nitrogen dioxide and nitrogen monoxide? Well, I'm looking for what? I'm looking at my coefficients in my balanced equation. What goes on top? We want to know moles of NO2, and what's my moles of NO, and how many? I have, what, 3 moles of NO2 and 1 mole of NO. So my mole ratio between NO2 and NO is 3 moles of NO2 to 1 mole of NO. Good. What's the mole ratio between, what is this called? Nitric acid. Yes, nitric acid and water. Well, okay, moles of nitric acid over moles of water. And then what do? I look at my coefficients. Where's my nitric acid? I have a 2 in front of my nitric acid, so that's 2 moles of nitric acid. I have a 1 in front of my water, so it's 1, so it's a 2 to 1 mole ratio. Good. How many moles of nitric acid would be produced if 5.27 moles of water were to react with excess? When you see the word excess, it means plenty, more than enough. With excess NO2, that means we don't have to worry about this because we're going to assume we have lots and lots and lots, and that this guy will run out before these guys run out. Okay? That we have 5.2 moles of water. What is it that we want? We want moles of HNO3. What is it that I have? Moles of water. Okay, so now let's go up to our balanced equation. Moles of HNO2, HNO3. Here's my HNO3. I have a 2. Where's my moles of water? I have a 1. It's a 2 to 1 ratio. Cool. So what's that equal? 2 times 7 is 14. Carry the 1. 2 times 2 is 4. 5 plus the 1. And 2 times, how about 10.54? 10.54. How many sig figs do I have? I have 3 there. Hey, what about here? Don't I have 1 sig fig? No. This is a count, really. This is a count. There's no uncertainty in the 2, and there's no uncertainty in the 1. So these mole ratios really have infinite sig figs. So that means my sig figs in my answer are going to be driven by the grams or moles given here. Got it? So that means I have 3 sig figs, and I have 10.5 moles of H2O. Zoink. I don't know if this is really a count. It's a definition. Sorry. It's more. It's defined. These mole ratios are defined. Okay. 10.5 moles of H2O. Any questions? Great. Let's move on. Back to, consider a Big Mac. Big Mac. Okay. How many slices of bun would you need if you had 82 hamburger patties? Okay, let's do this one. Slices of bun. Okay, well, we have to figure this out again. What? 2 all beef patties, special sauce, lettuce, cheese, pickles, onion on a sesame seed bun makes a Big Mac, right? So this is my equation for making a Big Mac. If I have 82 hamburger patties, how many? Okay, 82 so I have 82 hamburger patties. Yeah, probably put HP, didn't I? Hamburger patties. And I want to know how many slices of buns I will need. Okay, so I want to find out slices of bun. How am I going to do that? Well, I can use my mole. Not only can I use my mole ratio to go like from here to here, I can use my mole ratio to go anywhere. So that means I can go from hamburgers to slices of buns. I can go from cheese to slices of buns. I can go from hamburgers to cheese. I can use these mole ratios for all of that. All I have to do is say what? I have 3 slices of bun for every 2 hamburger patties, right? Okay, so what is that? So 82 divided by 2 is 41. How about 123? You guys buy that? 82 divided by 2, that's 41. 41 times 3 is 3. 123. So 23, you know, 123 we'd say. Since we're talking about hamburgers here, we won't do our sig figs yet. So we need 123 slices of buns to make uh, to use up my 82 hamburger patties. How many pieces of cheese would I need? Okay, how many pieces of cheese? Okay, once again, I have 82 hamburger patties. I want to know cheese. So what do I need? I need to multiply that by a mole ratio of cheese to hamburger patty. How many hamburger patties? 2. How many cheeses? 1. It's 1 cheese for every 2. So that looks to me like my answer is 41 pieces of cheese. There we go. So if I wanted to use up 82 hamburger patties, I need 123 slices of bread, 41 pieces of cheese, and how many Big Macs would I make? 41. Cool. Now, we can use that same principle with something like this. Oops, 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 oops. There we go. Consider my dinitrogen pentoxide decomposition again. If I have 1.872 moles of oxygen, that means I'm starting here. How many moles of nitrogen dioxide would I produce? So I'm just going from here to here. It doesn't matter where I go as long as I use my proper mole ratios. I can go anywhere in these equations. That's what's cool about the mole ratio. What is it that I want? I want I want nitrogen dioxide, NO2. I want moles of NO2. I want 4 moles of NO2 per 1 mole of O2. And so I'm going to have to actually use my calculator here. I guess I could do this in my head, but I'm getting kind of lazy now, right? So I have 1.872 divided by 4, and I get 0.4680 moles of what? My moles of oxygen cancel. I'm left with moles of NO2. There you go. Isn't that a blast? You guys try this one? Bring me back when you're ready. Hey, this is easy stuff, isn't it, ladies and gentlemen? All I have to do is figure out what I start with, 62.7 moles of NO, figure out what I want. I want moles of NO2, multiply it by a mole ratio of those two things, put what I want on top, moles of NO2, put what I have, moles of NO on the bottom, fill in my ratios by looking at my coefficients. NO is here, so I put a 1, 1, NO2, where's NO2? NO2's here, it has a 3, 3 to 1. So I'm going to take my 62.7 times 3 divided by 1, and it looks like I have 188.1. How many sig figs? 3 sig figs. So my answer is 188 moles of NO2 because my moles of nitrogen monoxide cancel. Yeehaw! How many moles of water are needed? Okay, so I start with what? I start here, and I want to go from here to figure out here. Can I do it? Sure. And how many moles of HNO3 would be produced? I start here again with from my number, and I can go here, right? It's easy. What do? I write down 62.7 moles of NO. What's the first one I want? Moles of water. I want to figure out moles of water. That means I'm going to multiply this by moles of water over moles of NO. I look at my equation. Moles of NO is a 1. Moles of water is a 1. So I have a 1-to-1 mole ratio. Piece of cake. I can do this with my abacus. 62.7 moles of H2O. Great. And then how about the next one? I want to know moles of nitric acid, which is equal to 62.7 moles of NO times what? 1 mole of nitric acid per, not 1, I have to look at just moles. I have to look up at my equation in a second. Moles of NO Let's look up at my equation. What's my ratio? Nitric acid is a 2 in front of it. 2 moles of nitric acid. What's my moles of NO based on the equation? Believe it or not, with all that writing, it is a what? It's a 1 in front of there, right? So 1 zoink. So 62.7 times 2 divided by 1 equals 125.4. How many sig figs do I have here? 3. So my answer is 125 moles of what? My moles of nitrogen monoxide cancel, and I have moles of nitric acid. That's it, folks. Hey, you guys are almost stoichiometric genii. Cool. All right, let's call it quits for the day. Wonderful. See you next time.